Hello and welcome to day 20. We're going to spend today looking at a bunch of proofs we've already done. Most are ones we've actually given you in the first place in the textbook. Others are ones that you've done but some time ago, so they should be sort of well in hand for you. And what I want to do is just go over the translation process. In the textbook, I spent some time talking about the difference between translation and transliteration. And what we really want is translation. The language of informal paper proof is just a different language from the language of formal proof, as it's done in Coq. Though what I want to draw out is that they're closely related. You just have to do different things in different ways. So for each of these 5 proofs I'm going to show you, I'll give you the provenance, where is it from? I'll give you the proof here. This is going to be the proof in Coq. And then I'll go through the proof in translation. So for this first one, I've actually given you 2 proofs, 1, 2. And these 2 proofs are, I'm aware that I'll go too fast. Thank you, OBS. These 2 proofs are just showing 2 different sort of ways in, one that more closely follows what's written in Coq, and one that is maybe a little bit more idiomatic. Okay, so let's get started. The first thing to notice is in paper proofs, people are often going to discuss things just using words. Equality is transitive. Now, what I've written after here is like i.e., and then I write a long proposition in sort of formal math notation, using LaTeX notation. There's a couple other things to note here in the way that I've translated it. So for one, a mathematician might only give this part, the equality is transitive part, not bothering to write the proposition, assuming that all the readers know what transitive means. Now, that's not a safe assumption in this class. We're just getting started. Hopefully, you all have it in hand. But, okay, maybe it's not a concept that's immediately at your fingertips like it would be for an experienced mathematician. No big deal. There's some other things I want to highlight. So Coq does this curried thing, right, where you see an arrow here, and this arrow is morally an and, but we've just written it as an arrow because that's how Coq works, and it's nice to have things curried. Whereas here in the informal world, we're really going to write the and. It's not uncommon, I didn't do it here, but it's not uncommon for people to write things in sort of a hybrid way. If n equals m and m equals o, then n equals o. So here what we would be using, if we had written it this way, we would maybe use the for all quantifier like usual, write these equalities using math notation, but then the rest gets written as words, right? All of these are great ways to go. Okay, so much for stating the theorem. The next thing I want to note is that in a Coq proof, you don't have to do any work to keep track of your goal or context. Coq does it for you. We have to do that all, right? Your human reader is going to do their best to keep track of the goal and the context, but reminding them sort of who the main characters are in some way is sort of a helpful thing, right? You want people to sort of be able to follow along. So what we'll do is throughout we'll say we'll do things like saying we must show. Let me get that a little clearer. Maybe do a different color. This we must show. So that we must show is stating the goal. Right? We can see it again here. Okay, what about context management? Well, what about it indeed? So here we see something like intros xnm eq1 eq2. Okay, that shows up in our proof here and here. Excuse me, I'd like a yellow pen. Thank you. Right, both of these are intros in a certain sense. Now I want to notice here that the intros kind of has 2 parts. There's like the intros, here. This is all data. These are like the values or whatever. Values. And then on this side, we get hypotheses. And then this such that is sort of a key thing in sort of like setting up reader expectations. So in Coq, there's no such division, right? The division would go here. Let me center that a little better. Here's the division, but it's all sort of the same, right? There's no real difference in sort of like introducing a type like X or values of that type like NMO or, hypotheses about values of that type like EQ1, which is N equals M. Here, maybe I'll write it here just so we can all keep track. Or EQ2 that M equals O, right? That's all just one intros command. Whereas in English, you kind of want to set up different expectations. There's a sort of, hey, here are the things that we have, N, M, and O. Notice that we don't talk about the type at all, right? The type's not important here, so it just doesn't come up again, right? It just like doesn't matter. We never talk about X in any way in our proof because it's just not important. But anyway, we let NMO be given of that type X. And then we say, okay, separately, remember this NMO I just told you about? I need particular ones. I need NMO such that, and then you state the hypotheses. So this is emphasizing that, look, the universe, who's the source of our for all quantified things, this could be anything. They give us one, we don't know anything about it. It's like, we don't not know anything about it. We know that N has to equal M and M has to equal O, right? So that queuing is really important. Okay. Let's do the rest of the proof. In this case, let's look at the translated proof, the one up top here first. Here we can still see a sort of one-to-one correspondence. So since N equals M by our first assumption, it suffices to show M equals O. Right, so here I've highlighted in red the tactic and then the text that it corresponds to. And then which we have immediately, okay, that, running out of colors here, I think I got it. It's lovely little slate baby blue, which we have immediately by our second assumption. Okay, so in the translated proof, you can see that there's a more or less one-to-one relationship of Coq tactics to things we say in the proof, but only more or less. There's other words that show up, like the things in green, the statement of the goal, that shows up. And then also there's the QED. I guess I can give that its own dedicated color while we're in here. Orange looks good. Right? The QED also shows up for each of these. Okay, great. Let's turn our attention to the more idiomatic proof. It says, okay, let NMO be given such that N equals M and M equals O. We have to prove that N equals O. Substituting O for M in the first equation, right? Why? So like if this corresponded to a tactic, it would be something like rewrite EQ2 in EQ1, and then this would be maybe apply EQ1. So that I think is a correspondence you could give. But the thing that I want to highlight here is that, look, the intuitive way to work often on paper is forward reasoning. That's what we have here in the more idiomatic proof. And the forward reasoning, okay, you can do in Coq. It's not going to necessarily be what your proofs do, and it's not always going to be a natural move in Coq. But I think here it actually reads quite naturally. We're like, look, we just saw M equals O, so I'm allowed to substitute O for M anywhere. So the first equation, we know what we're talking about. The first equation, when we see it, okay, first equation, that refers to this, right? And then this bit comes from this bit. Let me do that in different colors so you can, when you look at the notes, you know what I'm talking about. What do we got for colors? Purple. This bit, that's messy. There we go, looking beautiful. So I think the reasoning here is hopefully pretty clear, but it doesn't exactly follow what we see in the Coq. One other thing I want to note here is a tiny bit of language that I think is sort of nice, is this as desired. So this is sort of, again, I mean, maybe the right thing to do is to use the same green highlighter that I used for the stating the goal, right? This as desired is sort of us saying like, and remember, that's what we were looking for. And that's not a thing you have to do for Coq. Coq is keeping track of your goal for you perfectly. But the humans reading your proof maybe less so. So it's nice to sort of give people sort of guideposts that say, and this is what we're trying to do, and now we've arrived at our destination and things like that, beyond the QED. Okay, that's what I have to say about this first relatively simple proof. we'll see some more interesting stuff as we go through. Each proof will scale up and let us talk about more and more tactics. I want to encourage you to go and read what's in the textbook. So I've talked about all of the points I talked about there, but the textbook goes into more detail and might clarify anything that I said that was unclear. Look forward to chatting with you all about it. Talk to you soon.